Hey guys, I just finished playing Rockstar Games Red Dead 2, and I'm going to take a look at today recreating one of my favorite missions where the player follows Arthur to a bar and a few whiskeys later the player is left feeling disorientated with a moving screen. This is commonly used in games to portray a drunk-like effect and can be achieved through a distortion fragment shader. So let's jump right into it. Let's start by creating a new project. Okay, for this tutorial, I won't be using Unity Pro as this is not necessary. And let's just make a start then by decorating our scene. So let's start with a couple of cubes. Let's make this 20, 1, 2, 20. And let's add a couple of walls just by duplicating that. So flip it on its x-axis and flip this one on the x and y. Okay, and we'll move both of these then into position. Okay, great. Just move those up. Okay, now we just need some content just to fill our scene out. I was looking on the asset store, Thatch Cottage. It just looks a bit more like Red Dead Redemption, and it's just a free asset. So let's just click import. It's done with that. Let's open it up and we'll drag the prefab into our scene. That's really big, so we need to just scale that down and just reposition it then. Okay, that looks great. As you can tell, it is just a free asset. It does not sit perfect. But we could probably fix that by replacing our floor with a terrain. So if we go ahead and delete that and let's insert a terrain. Okay, the terrain is massive. So let's go ahead, let's bring that down a bit. As we will be moving it, let's just go ahead and turn off the light map static. We'll turn that back on later. Just it tries to keep recompiling every time I move it. Okay, yeah, that is going to work. And so let's start drawing. We just add a bit of a bump to the terrain. It will kind of look a bit like snow. It's a cheap way of doing things, but it might just help the visualization of the effect, the post-processing effect that we're trying to achieve. So just add a bit of snow. Let's pretend that there's been significant snowfall and it has settled around the base of our building. Okay, that'll do. So, if you haven't already, let's go ahead and we need to import the post-processing struct. To do that, if we go to Window, Package Manager, All, and we'll download post-processing. This might take just a couple of minutes to install. When that is installed, we can go ahead and add the post-processing to the camera. So if we add a layer and a volume as well, let's set that layer post-processing, and we'll do the same on the camera itself. And let's go ahead and check is global. Oh, and now that we won't be editing the terrain anymore, we can go ahead and turn back on light map static. Okay, once the light map is finished baking, let's jump back into our assets folder, and we will create a post-processing profile, a C# script, and a shader. So, post-processing profile, let's say PPP drunk. We'll create a C# script, PPP drunk, and the shader, standard surface shader. Okay. Alright, if we open up the C# script, we just need to set up some editor variables and reference the shader that we want to update. On Unity's GitHub, they already have some documentation on writing custom post-processing effects, and I find that this is just a good place to start when writing any post-processing shader. As well, I can never remember the exact structure and format that they require, because Unity does quite a lot of serializing the Unity editor variables and sending them across to the shader to interpret. I'll leave a link to this page in the description, but yeah, if you go ahead and you copy the C# code, which then we will put into our C# script that we made. If we just go ahead and we'll replace everything, we gotta remember to change the class back to whatever you called yours. I called mine PP drunk. And let's just replace anywhere that says grayscale with PP drunk. Okay, and the shader, it's not going to be in the hidden folder. Yeah, since we're not looking a grayscale effect, we won't be needing this parameter. Instead, we're going to be adding two new floats, amplitude and frequency, to make our screen woozy. So let's just rename this. We're going to call that, let's say, drunk distortion effect intensity, and yeah, we'll go from 0 to, yeah, let's go 0 to 1, that's okay. Float parameter, let's call this amplitude, and yeah, the float parameter not 0.5, okay. And yeah, let's duplicate both of those lines, and then we'll call this drunk distortion effect frequency, and yeah, we'll call that frequency, and this time we'll go from 0 to 100. We want to be setting the float on the shader, so let's just duplicate this twice. Let's call this one amplitude, and this one, just remember you need to use underscore if that's what we will be using on the other page. It's just good practice. And settings dot amplitude and dot frequency. Okay, that's just done for the C# code, and let's jump into the shader. If we take another look at Unity's GitHub for the post-processing, they have some pretty useful information on the layout required for creating a shader inside of Unity. So if we just want to go and copy that, and we'll bring that into Visual Studio, and we'll just replace what we have. Yeah, we didn't have ours in a hidden folder. We used custom ppp drunk. Yeah, we can access the post-processing library directly in the latest version, and we sent through amplitude and frequency. Yeah. Now we're writing inside of a fragment shader, which is going to just loop over every pixel. So let's store that as a float 2, so that's storing the x and y position for each pixel. We can call that the UV equals I dot tax chord, and then we need to be storing the distorted pixel. So we'll create that up here. Let's float to distortion. We'll create another. So now there's a couple of different curves we could use. Might be nice actually to have the x and y use different curves to make it feel more bubbly and disordered. If we just jump onto Google, sine, cos, tan, images. Yeah, so the sine goes from a 1 to -1, which will work quite nicely when moving these pixels to get a nice fluent distortion. So if we started off by sine, we can multiply by time. Time comes through with 3 values, x, y, and z, each with their own speed. I find that x is maybe too slow for what we're after. So we're going to go with time.y, and we will multiply that then by the frequency. Now, I'm just thinking we might also need to be sending through the speed and the size of the distortion, or it might be a little overwhelming. So we just jump back to our C# script. We're just going to add 2 more values. So we're going to send through, well, we can't actually send through a vector 2 across to the shader. It has to be vector 4, although we're only going to be modifying x and y. So we'll only be modifying 2 of the 4. So let's start off tooltip. This will be the speed of the distortion. Put a note to ourselves that only x and y used. And we can write public vector 4 parameter speed, and we will write some defaults, probably 1 and 1, so that we can modify it later. Oh. Value equals new vector 4 1 1 0 dot 0, and we'll duplicate this. Well, what's that not like? And we will duplicate this for the size. Again, 1 1 0 0. Now we need to send this through to the shader. If we just duplicate the set floats, we'll change that to set vector. And that was underscore speed and underscore size. Now back on our, is that right? That's a vector. Now back on our shader, let's just add those in. They were float for speed and float for size. Now our sine wave, we're going to be wanting to maybe times time by the speed that we sent in. So that will be underscore speed dot x, because we're modifying the x axis of the pixel. Let's just wrap that in brackets, and that will be multiplied by the frequency, and then adding the current pixel and its size. So if we set uv.x, and yeah, we will times that then by the size, our new size that we've sent through. That'll be size.x, yeah, times frequency, and we will multiply that again by the amplitude. So we need to wrap that in brackets. Times amplitude, yeah. And we will do the same for yeah, for the y. Set speed dot y times time dot y. That's correct. UV y and size y. Okay, so we have the float luminance that came through with the grayscale that we copied in from the Unity's GitHub, so we can just comment those out, we don't need them. And the pixel we want to be, yeah, we want to be using the initial one that we recorded, which is UV, plus the distortion that we've created. And yeah, let's just return, yeah, we'll return that. Yeah, let's try that out then in our scene. If we go to our post-processing profile and we'll add effect, custom, add our PPP drunk. We then need to add that post-processing profile to the camera. If we open up camera, yeah, we'll drag and drop the post-processing profile in. So if we go and play, yeah, we can see then by turning on the values on our post-processing profile, we'll see how they modify the scene. Oh, I've received an error. Where did that come from? Size. Okay. Sorry, they were capital. We just go back into the scene. Okay, error's clean. Let's play that again. We'll turn it on. Okay, so you see it's taking a large circular motion. Yeah, that was caused by, I think, what did we have two sine waves? We could maybe change this to cosine. We might receive a different effect. Okay, so yeah, now it's just much more bubbly. It's very distorted though, but we can modify some of these values that we're passing through. So the amplitude, let's take that down a good bit. The frequency, we can move that up. The speed and the size are good though, we can keep those as they are. Let's just modify that frequency just a bit. What we need now maybe is sort of wash it out a bit. Let's add a bit more color, so like a green color, just to make it feel a bit more woozy. So we'll create another C# script and shader and another post-processing profile that we're going to be working with for the color, because it's good practice just to keep adding profiles just onto the Unity processing rather than working within the one script. So let's call this ppp drunk color shader. Ppp drunk color and post-processing profile. Okay, so if we open up the C# script, yeah, let's copy what we did previously and we'll bring that across. We will just be needing this time, we need to change this to drunk color. Okay. Now we'll probably actually take from what we wrote, or what Unity gave us for their grayscale. We'll do something just very similar to that. So let's call it like saturation. So it'll be another float, saturation, and let's go from a value of 0 to 1. Yeah. Drunk saturation effect intensity. Set float saturation settings dot. Okay. And let's go back into Unity and we'll open up the shader. Once it compiles. Okay. If we copy the old shader, strong color, our float was saturation. Donate those. Okay, so this can be i.textcord. And we can keep the luminance in, RGB, color, luminance, saturation, and return that color. So if we go back into Unity, add that shader to the new post-processing profile, and let's add that then to the camera. So you can already see here that changes do take effect in the editor. I can add that on and see as I move, changes the saturation of so I think in Red Dead they had it quite desaturated, but still enough that you had some that you had a little bit of color, and then they added another green layer over the top of that. So if we just jump back into that color shader that we created, let's just modify those color values. Let's add a wave to the green and the blue. So if we do color.g plus assign time.x, because we want this to be quite a slow, the wave had to be fast, but the color change should be maybe gradual. So if we do time.x, we can multiply that by 2. It's still slower than having it by .y, and we'll do the same for b. Now, because the sign goes from -1 to 1, the axis in G, or the color, will go from pink to green, which we don't want to be seeing pink. We just want to have some light contrast between green and blue. So we need to set this to be the absolute color, or the absolute value of sign, so that's always going from 0 to 1, which means that we're always going to have a green hue to our camera. So let's add absolute to the blue as well. If we go to play that, okay, if we press play, okay, you can see that the color is starting to get a more blue hue. We need to heavily reduce the blue whilst having still a good bit of green left. So we stop playing, let's jump back into our code. Yeah, let's reduce that blue, and we can maybe reduce the green as well, but we won't reduce it as much as the blue. I press play. Okay, yeah, that's quite a nice effect, and well, that's really it. We can just play with some of these values. You can change the speed, how drunk do you want your character to be. I definitely wouldn't advise this for a VR. So the size, it's maybe quite nice to actually make the size different on the Y, because we get like a stretching effect. I'm quite happy with some of these values, and that really marks in the end of my video. I hope that it's been of use. I make videos because it really helps me get to grips with the code I'm working with. So I hope it has been of help to you. And if you liked this video, please leave a thumbs up, hit the bell for notifications on future videos, as I plan to be doing more, and do subscribe. Yeah, it will only encourage me to get more videos out, and see you guys next time.